The concepts of pH and buffers are vital for food safety officers, forming the foundation of appropriate food handling practices. pH measures the acidity or alkalinity of a solution, which significantly influences the growth of microorganisms. A neutral pH of 7 is ideal for most food products. Understanding this concept allows food safety officers to prevent spoilage and ensure the safety of food consumed by the public. Buffers are solutions that resist changes in pH when acids or bases are added. They play a crucial role in maintaining the stability of food products during processing and storage. Food safety officers must be aware of the operational pH levels in various food items to safeguard against detrimental chemical reactions that could occur if pH levels fluctuate. Key point 1. pH scale ranges from 0 to 14, where lower values indicate acidity and higher values indicate alkalinity. Key point 2. The optimal pH for food preservation typically lies between 4.6 and 7. Key point 3. Many pathogens thrive in neutral pH environments, underscoring the need for careful monitoring. Key point 4. Buffers contain weak acids and their conjugate bases, which help stabilize pH levels. Key point 5. Common buffers in food include citric acid, acetic acid, and phosphates. Key point 6. pH influences food texture and flavor. Lower pH can enhance acidity and freshness. Key point 7. Certain food processes, such as fermentation, rely on maintaining specific pH levels for desired outcomes. Key point 8. Regularly testing the pH of food items can reveal spoilage patterns. Key point 9. Food safety regulations often require adherence to specific pH levels for various food products. Key point 10. The knowledge of buffers and pH is essential in risk assessment and managing food safety protocols. Frequently asked questions. What is a neutral pH? How can I measure pH levels? Why is pH important for food safety? What types of buffers are used in food? Can pH affect food shelf life? How does pH influence flavor? What is the ideal pH for canning? Are there pH limits in food safety regulations? How do I adjust pH levels in food processing? What role do buffers play in food stability? Multiple choice questions. 1. What is the pH of pure water? A. 0B 7C 14 2. Which acid is commonly used as a buffer in food? A. Citric, B. Sulfuric, C. Hydrochloric. 3. At what pH do most pathogens thrive? A. Below 4.6, B. Above 7, C. Neutral. 4. A buffer resists changes in pH by A. Diluting acids, B. Reacting with acids and bases, C. Heating solutions. 5. What is an example of a buffering agent? A. Sugar, B. Salt, C. Bicarbonate. 6. Lowering pH can impact food. A. Texture, B. Shelf life, C. Both. 7. pH levels can be adjusted using A. Chemicals, B. Temperature, C. Air. 8. Regulations often specify pH limits for A. Fresh produce, B. Canned goods, C. All food items. 9. Which pH is considered acidic? A. 2B 7, C. 10. 10. Understanding buffers is essential for A. Cooking, B. Food processing, C. Food tasting. We encourage you to subscribe and leave a comment on the Food Technology YouTube channel for more insights and updates on food safety topics.